Hello students, welcome to Misostudy video classes, and as it is clear from this first slide, today we are supposed to discuss some good questions based upon the NEET medical entrance exam pattern. Fine, and the topic or chapter is very important, that is EMI, electromagnetic induction. So let us start this discussion, but before that I would like to mention certain amount of some mathematical steps are required. What I will do, I will mention them properly. Fine, we will not go into the depth of the solution, but we will try to find out the concept. Okay. So here with let us start the discussion. Here it is your first question. Now an electron is moving in a circular orbit of radius capital R with an angular acceleration alpha. I hope the first line itself giving you the clarity of the diagram or the situation. At the center of the orbit is kept a conducting loop of radius small r. Obviously, small r is very less than capital R. The EMF induced in the smaller loop due to the motion of the electron is how much? Now the question is simple, and I just tried to use a basic concept of revolving electron to explain this problem. Now what I will do, the question is present over here, I will use this space to explain the situation of this particular question, and after that also certain aspect. Fine. So let us start the solution of this problem. I will only mention the required steps, and in this explanation if some portion of the questions are not visible to you, I hope you will not mind it, because here I am giving you the proper explanation. So this is the question. Now let me allow to present over here, and this is the formula required for the solution of this problem, that is A dB upon dt. Now A is equal to pi r square, you know that circular area. So what I will do, this B is something that is given as, directly I am writing the formula, that is mu naught upon 4 E r square alpha upon r. Now few of you will start thinking, what exactly the expression of the B? If any one of you is thinking like this, my simple suggestion is, please go through with the videos of this particular chapter once again, but here I am going to help you out. I will mention the value of V. Fine. So the value where B is equal to mu naught upon 2 into q omega upon 2 pi r. I hope now the entire explanation is clear to all of you. So on the basis of this mu naught upon this particular expression, B is the correct option, that is mu naught E r square upon 4 r into alpha. So this question is a basic simple question. Fine. Now I have to move ahead. So let us clean this board so that we can get ready for next problem for the discussion. So here comes your question number 2. Now this question is not a difficult one, just because of the language this question is long, otherwise it is a simple question. A square wire loop, you need not to mention anything, everything is mentioned in this diagram, of 10 centimeter sides lies at right angles to a uniform magnetic field of 20 Tesla. I hope small some these crosses are visible to all of you. This is just a representation of the magnetic field perpendicular to this green board inside. Fine. A 10 volt light bulb is connected in series with the loop as shown. The magnetic field is decreasing steadily. It means magnetic field B is starting from a top value reducing to 0 in delta t time. Okay. The bulb will shine with full brightness if delta t is equal to time interval, means maximum current will flow after how much time? That exactly your problem. This particular question is nothing but based upon the formula which just 2 minutes back I explained for the first question. So, let me allow to write all these formulae once again for the solution of this problem. Del B, sorry, it is A dB by dt. Who is changing with respect to time? This B is changing, fine. So, what I can write down that this dt is equal to A dB upon, no problem, simple, you have to find out delta t. So, all other values are given, putting values from question as given. So, I am not taking a lot of time, putting values from question, fine. Once you solved it, so delta t you will get at 2 millisecond. Putting values I am just leaving because there is no point of putting the values and solving this multiplication, division, etc. Important is concept. Now, forget each and everything, just concentrate over here. Okay, this is your crux of the matter. If this formula is clear to you, then whether V is changing, whether A is changing, induced EMF will come into picture, fine. So, my emphasis by using these two questions is simple. I want you should know this formula, that is it, because in this entire chapter there are just few formulae. Okay. So, now let me allow to clean this board and we will move ahead for the discussion of next problem. So, here comes your question number 3. Now, the magnetic flux, magnetic moment, this sentence comes into your mind, phi B is equal to B A cos theta. This formula should come in your mind anyway. With resistance R varies during interval of time t as phi is equal to AT into t minus t. The heat generated during this time neglecting the inductance of loop will be how much? Ultimately, in this question also they are asking about induced EMF, only then you can find the heat H is equal to I square R T type of relation. Okay. So, from here we will start our discussion of this topic, I mean this particular question. Now, once again the same formula, but in a different manner, that is equal to d phi B by dt. What you have to do? Differentiate phi with respect to time t once, that easily you can do. Although you are preparing for medical entrance exam, but I know, I can understand that small steps in integration and differentiation, very simple, you can do that. Okay. So, from here after this what I can write down? I can write down after differentiation it as AT minus 2AT, fine. This is something which we can write down, AT minus 2 small t, rather not capital T, fine. From here heat generated is heat H, class 10th formula I square RT. So, same type of thing we will do, and how exactly we will do that? That is square R dt, fine. Put the value of this square and differentiate it. So, simply what I will write down, after solving. Now, even if you picked previous year's question papers of NEET medical entrance exam, you will find at least around 20 to 25% questions have some sort of calculations, not very difficult, but yes, some steps are there. So that is why I am putting these questions. Now after solving, obviously integrating and solving it is not a big task, fine. So first is differentiation involved, then integration. So answer is going to be a square t cube upon 3r. So if you just take a look of this expression, from here you can easily say that a square t cube upon 3r, that is a is the correct option. Now with this question, what I want to prove, what exactly my motive is? Simple. In one question I used integration and differentiation both, fine. Also I use this formula in a different aspect. My motive is clear. Number one, these basic mathematical tools, utmost important. Please just make yourself comfortable with these small steps. Number one. Number two, you should know if I am going to do some sort of makeup with any specific result, then what exactly the resultant result that will be come out, fine. So there is a twofold motive for this particular problem, and I hope you will appreciate this effort where I am putting so many situations in front of you so that you can easily revise your basics for the understanding of the topic. Now here comes question number 4. Well, this question is out of 45 questions in physics, you will find 4 or 5 questions are so difficult, so long, so complicated, while it is not truth. If this type of question is given, then obviously a medical stream student, 90% what they will do, oh my god, let us move ahead. I want to change this habit. Please, it is not like that. Try to understand the problem. In a cylindrical region having radius r, this one is, magnetic field varies with time as B is equal to A plus BT. If the concepts are clear, understanding this line is not a problem. With time the magnetic field is changing. So ultimately changing magnetic field producing this induced EMF. OPQ is a triangular loop made up of wire having resistance per unit length lambda. Find the current induced in the loop. Fine. Question is simple, diagram is given. Now I am going to explain you how to find out. Okay. So just take a look properly. Triangle OPQ. OPQ. I am writing over here. I am repeatedly saying about this explanation. You just have to listen and take a look over here. If required and diagram is visible, you can quickly take a look of the diagram also. Triangle OPQ, PQ is equal to root 3R. This is something which is based upon the basic algebra, and OQ is equal to 2R. Fine. So these two values. Now as such there is no difficulty in understanding this situation, but I mentioned, I hope now it is going to be the part of your video. So you will repeat it, revise it whenever required. Take a look of this diagram. Triangle is clear and the values are given. This angle is 60 degree. Now I am cleaning this portion. Okay. It was initial introduction. Now resistance, what I am trying to do, I am making these explanations as simple as possible. In this particular question, whatever I mention using basic algebra, you will say, oh, no problem in that, fine. Now resistance of what? Resistance of loop OPQ, fine, because it is a wire. having resistance lambda per unit length. So, resistance of loop OP Q is equal to lambda and then total length, fine. So, lambda and 3 plus root 3 r. Yes, I think I should write this r with a different color, r, fine. So, this is the total length of this, that you can say, take it out common, like root 3 lambda r root 3 plus 1. This is something that you can, any point of time you can do that. Okay. Now, this is nothing but arranging the terms. Now, I induced is equal to A by R dV by dt. As such, now even my support is not required. I hope after this much easily you can put the values of B, differentiate it, and you will get the resultant as I induced is equal to pi r b root 3 minus 1 upon 12 root 3 into lambda. Actually, students, in competitive exams, few questions are asked keeping in mind this fact that any student who is attempting them and solving them properly definitely deserve a good rank, maybe in AIIMS, maybe in any other good medical institute, fine. So, obviously, it's age of competition, cutthroat competition. Try to recall that scene of Three Idiots movie, fine. So, ultimately you have to work hard, and the message by this question I want to give only this, fine. You can't help out, I can't help out. You decided yourself that I will become a good doctor. So, whatever they will ask, you have to do that, okay. This question is question number 5. You will say, oh my God, that was so big and this one is so big. Not like that. Be careful, listen carefully. The figure shows an isosceles triangular wire frame, and here I am sure you can easily look this small faded cross, that is nothing but representation or showing you the magnetic field lines. Apex angle this 90 pi by 2. The frame starts entering with velocity v, find uniform velocity. The longest side of the frame is perpendicular to the direction of velocity. This one is the longest side and this is the velocity. If I is the instantaneous current through the frame, then choose the alternative showing the correct variation of I with time. You need not to calculate, you just have to visualize and then you can find out the expression and then this graph, okay. So, I hope the diagram is clear. Let me allow to explain it. I am going to write down a formula which is repetition of the previous formula, okay. I induced, what was the previous formula? Fine. This is something that is a good habit to practice writing again and again, that is B upon R, resistance, magnetic field, that is B upon R dA by dt. Area is changing because of the entering of this triangular shape, fine. Now, what exactly is essentially required, that is B upon R V square into 2D, that is B upon R into V square into 2T, as from this relation, okay. So, B upon R V square into 2T. Now, what you should do, B upon R out, d by dt, at the place of A you should write down this expression, fine, as I is equal to B upon R d by dt 2 into 1 by 2 into B naught into H, fine, nothing, just I am writing in the terms as it is given. So, from here after solving you can say I induced is directly proportional to T, and from here if you just take a look, then only graph which is representing this situation is this one. It is nothing, class 10th, V is equal to IR, V is directly proportional to I, that Ohm's law type of diagram. So, is it like a difficult situation? Not at all. Here the only important aspect is, if rather than this triangular shape wire, I introduced a circular wire, rectangular wire, square, calculating area is simple. Here area calculation is slightly tricky, that is it, fine. And few things deliberately I am not explaining, reason being, if I will explain each and everything in these PPTs, what you will do, you will not revise any concept. But here I deliberately, if I am not explaining anything, then it will start creating a problem. You will say, okay, what is that explanation? That way you will definitely go back to the basics, revise, and exactly I want that. That is why I am doing this thing. Deliberately in between steps I am missing something. That is something which you should have to work out. Because explaining each and everything, I mean, hot cooked, properly cooked Maggi if I am giving you, it is not going to helpful for you for your competitive exams. Here another question. So, these 3-4 questions in sequence are slightly difficult, and the message by these questions I want to convey is, yes, you should mentally prepared for these type of questions if you want to score a good rank. Fine. Simply you can't say because I am not mathematics background student, so I will not do that. No, you can't. Two conducting rings P and Q mentioned, of radius R and 2R, moving uniformly in opposite direction 2V, V, with center of mass velocities 2V and V on a conducting surface. This PSQ surface is a conducting surface. Let us say it is made up of copper or something like that. There is a uniform field of magnitude B perpendicular to the plane of the rings like this. The potential difference between the highest points of the two rings is how much? Question is simple. Simple in the sense, it is a combination of two questions, and magnetic field is perpendicular to this green board outward towards the camera. Fine. So, do not forget this aspect over here, and I hope you will find yourself in a comfortable position. Now, I am writing the formula. Motional EMF is BLB. This is the basic result. We discussed for the aeroplane. We discussed for a tanker carrying petrol or diesel. A chain is hanging, something like that. So, motional EMF is BLB. That is, now one is you can say this smaller circular conducting wire, another is bigger one. Fine. So, EP minus EQ. Okay, no problem. I hope that is B into 2V into 2R. It will give you 2 to the 4 BRB. Fine. This is situation number 1, initial situation. And then situation number, basically you can say this is A position, this is B position. When they move away, they are now on a different position, something like that. Fine. So, I can represent it P and Q, you can represent it A and B, something like, no problem on that. So, 4BRB, that is equation number, let us say 1. Now, when they move further apart, then what will be the situation? Let us say that situation is given by ED, EC. Either PQ or AB, when they move P1, Q1 or D and C, anything like that. I am just representing the different possible situations. So, it is BV into 4R. So, again it will give you 4BVR. Now, this is equation number 2. So, sum up of 1 plus 2, 1 plus 2. That will give you initial minus final, and that too with minus sign. Okay. So, it is E P minus E C, that will give you 4 VBR minus of 4 VBR, that is 8 BBR. So, it is the simple solution of this problem 8 VBR. As such, this problem is anyway not a difficult one, just some visualization is required. Now, because these few questions were slightly long questions, I hope the message is clear that yes, I am forcing you, you should try to prepare yourself for these type of questions also. And this is not a difficult aspect, very simple. Here comes the next question, and this is a simple one. A rod of length L rotates in the form of a conical pendulum like this. This is a rod and it is rotating like this. Okay? This is the derivation of this chapter somehow, with angular velocity omega about its axis as shown in this diagram. The rod makes an angle theta with the axis, this theta, this way. The magnitude of the motional EMF developed across the two ends of the rod is how much? Actually, the derivation given in your chapter is like this. Here I am changing the scenario slightly like this. That is it, fine. So, you can say it is the application part of this particular concept, that is 1 by 2 B omega L square. I hope you all will definitely smile by watching this. So, it is 1 by 2 B omega. Now, a story is hidden behind this L, and this L is nothing but L sin theta whole square. It is the formula when the rod is rotating like this, and this is the formula when it is moving in a conical pendulum. So, directly formula based question, just checking, are you in a position to recall back that formula or not? Recall back 10 seconds, only 10 seconds for this question. Imagine the beauty of physics. So, do not take these things like very difficult one or so on. No, not like that. They are not like that anyway. Then it comes question number 8. When a J-shaped conducting rod, let me explain you the diagram once again. I have a rod. So, moment I will say I have a rod, you will imagine like this, okay? But here the rod is J-shaped. What is the meaning of J-shaped? J-shaped means rod is like this. I am sure you must have noticed this type of wooden stick with old people. They use it to support their movement, fine. So, something like this, okay. So, a J-shaped conducting rod is rotating in its own plane. This is the situation, rotating like this. This is one rod rotating like this, but I have a rod which has some portion over here, then it is rotating with angular velocity omega about one of its point, that is P, in a uniform magnetic field. I hope it is visible, small cross field B directly normal into the plane of the paper inside, I mean this green board. Then magnitude of EMF induced across it will be how much? If you forget this portion, question is simple, but if the portion is curved, then what will be the answer, okay? And after getting the solution, you will say, oh, this is the solution of this problem. 2, let me write down in a different manner, fine, otherwise I was supposed to write down half, omega L square, same result, no difference, okay. That is V omega by 2 under root L square plus L square, fine. It was a situation where I was trying to say I have a rod. and there are certain possibilities for the rods. So, I am mentioning all those possibilities. Simple, again formula based question, nothing difficult. So, shun this habit of saying that, oh, this is such a difficult subject. This is not a difficult subject, it is a very simple subject. Let us move ahead on to next question. In the circuit shown, A is joined to B. A is joined to B like this, for a long, then A is joined to C. So, first A is joined to B like this with the help of a wire. After some time, 10, 20, 30, 40 seconds, this joined to C. Actually, what will happen? When you connect with it, what will happen? The current will flow over here, energy will stored over here, and when you will connect it in this fashion, now the battery is disconnected, this energy will be utilized in this resistor. The idea is simple. The total heat produced in R, how much? So, the total energy stored over here is the total energy produced over here. Ideal condition, fine. That is half Li square. Not a difficult aspect. This is the total energy stored in the inductor. So, you can say half into 2L into, yes, half into 2L because the value is 2L, half into 2L, that is why I should write upon 2R whole square. That is your answer. Fine. This is the value given. That is why I am using this result. So, this question again, diagram is big, situation, purely concept based question, purely concept based question. Why? Connect, because of the battery flow. Disconnect, connect, because of the energy stored in this inductor. Simple. And then this diagram, uniform magnetic field, it is mentioned like this, perpendicular to plane of loop, this is 2 ohm, this is B, this is R, this is 0.1, this is 3 ohm, this is D, this is A, this is C, this is B, 0.1 ohm, this is magnetic field. The magnetic induction is 0.1 Tesla and resistance of connector R is 1 ohm. Fine, given it is over here. The sides AB and CD, AB, I hope it is visible to all of you, and CD. Actually, this line is quite bright and this is something which is not that much bright, just to show you the difference. Fine. The sides AB and CD have 2 ohm resistance and 3 ohm resistance respectively. Find the current in the connector during its motion with constant velocity 1 meter per second. This velocity value, this V value is given 1 meter per second. So, yes, allow me to solve this problem. I is equal to B V L upon R net. I hope everyone is comfortable with this formula. That is, R net is nothing but 2 plus 3 upon 2 plus 3, 2 plus 2 into 3, into 3, 2 plus 3 plus 1. As the values are given, this is parallel and then this series. So, it will give you 2, 3 just 6 upon 5 plus 1. Fine. So, that will give you, after putting the values, after putting the values, all these numbers are there, you will get it as 5 upon 100, that will give you 1 upon 220 ampere. After watching these videos, many students used to comment like that, sir, kindly provide the entire step by step solution. I will say no. Why? Because I want my students to be independent, to be strong enough to face the question paper inside the examination hall. If I will provide the entire solution, you will not work upon, and then definitely you will not gain any knowledge. because ultimately in examination hall you have alone, you have to fight with your enemy, that is question paper. So mentally you should prepare yourself. If any concept is giving you a problem, I am always with you, but if calculation is giving you a problem, I will say please work out. Anyway, with this positive suggestion, I hope few of you will enjoy, few of you will say, oh my God, again forcing to work hard. There is no alternative for hard work. So keep revising, keep working on these directions, take care of yourself, have a nice time. Thanks.